Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge binary tree maximum path sum. So let us first read this question, then about the constraint, examples, and then finally the coding part for the same. So here, a path in a binary tree is a sequence of nodes where each pair of adjacent node in the sequence has an edge connecting them. A node can only appear in the sequence at most once. Note that the pair does not Note that the path does not need to pass through the root. So basically, that does not need to be that simply means that it can be or it cannot be passing through the root. And the path sum of a path is the sum of nodes value in the path. Given the root of a binary tree, return the maximum path sum of non-empty path. So basically, whatever binary tree which is given to us, we are required to return the maximum path sum. So according to that only, we are required to do this particular question. So first here, if we see this particular, so maximum possible path of this particular example which is there is, it could be directly 2, 1 and then 3. That is 6. This could be the maximum possible path. Now let us check for the second example which is being given to us. So here, maximum possible path which could be calculated is if you go from 9 to minus 10, right? So here it is minus 10, then because of minus 10, we will be getting something which is till now we will be getting 1 as the path sum, right? So that's why rather than going towards this path, let us check for this particular path. So if we add this up, so we come up with 42, which is maximum possible path which could be obtained. Because if we take minus 10 into consideration and check this path or minus 10, then this path, is any of these, if we take them, means if we take this particular path, or if we take this particular path, or if we take a path like this, right? Any of them won't be the maximum possible path here. So that's why the maximum possible path which we can figure out till now was this one only. So, uh, was this one only. So that's why after doing that, we got this 42 as the answer. So like this only, we are required to figure out each and every possibility in our binary tree so that we can check with that path which could be our final answer. So now, as per the constraint which we can see here, it is 10 raised to power 4. So order of n means this type order of n or order of n log n. Both of means either of them solution could work, but n square won't work here. So we are required to go ahead with solution something like that. And here we can see that negative values are also there and positive values are also there. And we are just adding them up. So long is not required as 10 raised to power 3 is there, right? So these are the things which we can check from these constraints. Now let us go ahead with the coding part for the thing. So here I have already coded the question because it is one of the standard questions. So I had already practiced this a lot of time. So now here, first I'm taking global maximum sum and I've taken it as initialized with int min because we require maximum path. And because of that maximum path only, I first initialize it with int min so that we can figure out that what is maximum, what is minimum. Hmm, Sorry, what is maximum, what is minimum. So in that context, now comes the next part. We are calling this find maximum path sum recursive. This will be giving us some conditions. This first condition would be when root is being included, right? Then second condition for the subtree, and in this subtree, either it could be left subtree or it could be right subtree. So out of these, we will be able to figure out means these two conditions, and then in these two conditions, after checking for above two condition, we will be having this global maximum. This global maximum will let us know about this condition and this condition. So for that purpose only, we are having this particular function where these three conditions will be fulfilled, is including root or excluding root. And if we are excluding root, then in that also left subtree and right subtree. And then finally the global answer, that checking for all the possibility and what would be the final answer. One minute. Okay. So now we are now comes the part that how we are required to do this question. First comes the part. Here we will be checking for the current node. If that particular current node doesn't exist, then we will be returning 0 as our sum. That's the thing. Now, for left subtree and for right subtree, marks path sum from left side. So for that, we will be passing the leftward node. So that would be thing. And the global maximum sum where we will be storing our final answer. And then comes the part for the right subtree, passing the right node and the global maximum sum. Now then comes the part max path sum from left. Because of this, now whatever maximum path sum we can obtain from the left side, that we are required to figure out that it should be maximum out of both of them. Means either it should be, means if it is negative, right? So negative and zero, what would be greater? Zero would be greater. So that's why we are taking these two conditions, because of which we will be able to figure out only positive values. So for that purpose, we are keeping this. This is for handling one of the edge case that when negative values are there. Now comes the part for the local maximum sum. Because in a particular subtree, that comes out to be a local possibility, right? So in that only, we will be checking for the maximum sum from the left side, then maximum sum from the right side, and the current value. Basically, I want to convey that if here you can see, let me show you. Okay, here. See, this particular is a local sum. How? The current node, then left subtree and the right subtree. So for handling this case, we are having this particular. So that is the purpose of this. Now comes the part of global maximum. So global maximum, it will be checking the whatever was being stored earlier. Say earlier it was having the 0, right? And then local maximum, it gave us 42. So because of that only, now global maximum will become 42. So that's why we are keeping store of two variables, local maximum for locally checking for that particular subtree and global maximum which will be checking for the that particular subtree and global maximum which is being there. Now, at the end, we will be returning maximum out of whatever from the left subtree and the right subtree. Not this one. Is whatever would be maximum left subtree or right subtree of this particular node and the node value itself. So this is what we will be returning to our parent column. So its parent column would be this minus 10. So that is how we will be handling for the root case also, for the left subtree also, for the right subtree also. And then at the end, we will be returning our global maximum, because here we can see that global maximum is being returned. How you can clearly see that it is being passed by reference here, right? So this global maximum value, whatever we will be obtaining from this particular function, would be returned toward this particular final answer, means would be returned here, and then this will be returned as an answer. So now comes the part for the time complexity and the space complexity. So basically, if it can become skew tree, so in that context, means if our tree becomes something like this, So the height of the tree, it will be equal to n only, right? So that's why time complexity is order of n and the space complexity is order of h, where h is directly equals to log n means this height. But if again it becomes skew tree, then again it will turn out to be n only. Means time complexity and space complexity for both of them is order of n only. So yeah, this was all for this particular question. If you have any doubt, you could comment that down. So yeah, thank you.